In this video, I will be talking about compact bone and spongy bone. Compact bone is located in the peripheries of most bone and is thicker in the diaphysis of long bones. The compact bone is the main structure in the body for support and protection and movement. Due to the strong nature of compact bone, compared to spongy bone, it is the preferred tissue for strength. Whereas spongy bone is also called canaculous or trabecular bone. It is found at the ends of long bones as well as in the pelvic bones, ribs, skull, and the vertebrae in the spinal column. It is surrounded by compact bone. Spongy bone is used for more active functions of the bones, including blood cell production and ion exchange. For the structure of compact bone, it starts with the Haversian system, which are cylindrical and structural units which compose the compact bone. They bear and transfer weight in its long axis. Next is the lamella, which is layered arrangements and fiber orientation which allow optimal weight bearing and even weight transfer. The lacuna is unfilled space in the bone cell which contains osteocytes. Canaliculus are small channels or ducts which allow small molecules, ions, nutrients, and metabolite passage between osteocytes. Next is the central Haversian canal, which are tube-like structures in the bone that contain blood vessels, house blood vessels, and communicate with bone cells. The matrix gives the rigidity and hardness to bone and is composed of a combination of calcium and phosphorus salts called hydroxyapatite. The structure of spongy bone, also called canaculous bone, it is called spongy bone because it resembles a sponge or a honeycomb, and it has many open spaces connected by flat planes of bones known as trabeculae. Inside the trabeculae are three types of bone cells: osteoblasts, osteocytes, and osteoclasts. Osteoblasts are the cells that make new bone. They produce layers of hard tissue made primarily of calcium and phosphate until they are completely surrounded, at which point they become osteocytes. Osteocytes maintain a connection with their surroundings via tiny channels called canaliculi. Finally, osteoclasts are larger cells that break down and destroy old or damaged bone so that it can be repaired and replaced by osteoblasts. This repair and rebuilding cycle is constantly ongoing to keep bones strong and healthy.